Right, we've got a continuation of 6.3 polar coordinates. Now we're moving on to some equations. And I bring this up mainly because, again, you've got these tools that you need to remember. um, we can substitute in or out or whatever. Um, so have these in front of you. Understand that we can plug things in. And any point is going to be represented here as a uh, linear or polar coordinate. So let's jump into the equations. We've got two rectangular equations, and we want to express them in polar form. Remember, polar form has r's and thetas, so we want to replace our x's with 3 times r cosine theta, and y gets replaced with r sine theta equals 6. We can distribute the 3's, but remember in this case we want to solve ultimately when we get down here. We want r equals something. So I would go ahead and just pull out the r and get r times 3 cosine theta minus sine theta equals 6. And now I can divide that out and get r by itself. R is equal to 6 over 3 cosine theta minus sine theta. And 6a is done. Solve for r. So we're going to do the same thing for the next one, but you're going to have to be a little bit observant. You don't want to just substitute r cosine theta, r sine theta into these things. Let's go ahead and multiply this out. So we're going to end up with x squared plus y squared plus 2y plus 1, and you guys can do the FOIL on that if you want, equals 1. The 1's clearly go away, and we're hoping we can substitute um, x's, y's, r's, something. If you have to, go back and take a look at these things. Is there anything that we know that we can substitute x squared and y squared for? Well, yeah, this x squared plus y squared is just r squared. All right, so if we replace that with an r squared plus 2 times r sine theta equals 0. And now you got to make a decision. Does the r make any difference, or can I just factor it out? So r times r plus 2 sine theta equals 0, and we now have two equations. This is your zero product property. Either r equals 0 or r plus 2 sine theta equals 0, which makes this r equals negative 2 sine theta. One last comment, I guess, about r equaling 0 means there's nothing there, right? So our result here is r equals negative 2 sine theta. And if you look back, that looks like it might be a circle of some sort, or a conic section of some kind. All right, moving on to the last example in this section. We are converting from polar to rectangular. And the first thing you got to consider here is that if we're substituting x's and y's back in, then we're going to have to do some manipulating. And in this case, one of the possibilities is just simply to square both sides. Okay, so if I square this and this, I get r squared equals 16. I get, in place of r squared, x squared plus y squared equals 16. It looks like I've got an equation of a circle, radius of 4. Oh, well, that's what that said originally, radius of 4. All right, part B. Theta equals 3 pi over 4. And again, you're going to have to take a look at that and understand that this is where the tangent comes in. And we're gonna substitute that in, simply knowing that tangent of 3 pi over 4 has to equal y over x. Well, we know that tangent of 3 pi over 4 is equal to some angle. And what angle is that? Sorry, not what angle, but what ratio is that? 3 pi over 4, that's going to be -1 equals y over x. If I multiply by x, I get -x equals y. Let's turn that around so we can see what it looks like. Y equals -x is a linear equation, and we are done. Part C, they're throwing at secant at us, and keep in mind we don't have anything for secants, but if I rewrite this as r equals -2 over cosine theta, and then multiply through, and we got cross multiply, right? We get r cosine theta equals -2. We can replace r cosine theta with x equals -2, and we're done. All right. And you guys, you need to start looking at these and trying to discern which method is going to work for each one. For D, instead of squaring this one, which is one of your initial reactions, let's treat it and just multiply both sides by r. So if I multiply this by r and I multiply this by r, I get r squared equals 10r sine theta. R squared we know is x squared plus y squared equals 10 times r sine theta is y. And if we bring that over, we're going to get x squared plus y squared minus 10y equals 0. And I'm going to say, you guys, if you get this, that's certainly sufficient. I will give you full credit for that. However, I think you can take this one step further. That one step further will have you complete the square. And if you remember completing the square, this goes x squared plus y squared minus 10y plus something equals 0. So in order to complete the square here, it's half this middle term squared. And if you add 25 to one side, you got to add it to the other side. That's a 5, trust me. So we have x squared plus y minus 5 quantity squared equals 25. And that puts us in vertex form, not vertex, but it's a circle with a center at 0, 5, radius of 5. So this, if you can get that, would be extra credit.